These days, we have a lot of high density screens with more pixels, and that's something you need to take into account when displaying images. So let's talk about a bit of history. In the past, we had iPhone 3 with a resolution of 480 by 320. Then in 2010, Apple introduced iPhone 4 with the exact same screen size, but with double resolution. So the resolution of iPhone 4 is 960 by 640, which means we have twice as many pixels in each direction, horizontally and vertically. This was the first generation of high-density screens, which Apple called Retina displays, okay? Now, let's say we have an image that is 320 by 320. If we display this image on an iPhone 3, it's going to look like this, right? Now, what if we display this on an iPhone 4? How big do you think the image is going to be? You might think the image is going to be half the size because 320 pixels take up half of the width of the screen, right? Well, that's not true. iPhone 4 has a scale factor of 2x, which means it's going to render each pixel of this image using 2 pixels on the device. So it's going to resize the image and make it twice as big. Now there's a problem here. Earlier I told you that when we scale up a raster image, our image looks a little bit blurry. Now, if we want this image to look sharp on iPhone 4 or any other high density screens, we have to provide a separate version of this image that is twice as big and then display it at the original size. I'm going to show you how to do this in a second. But first, let's define a few terms. Our devices these days have a few properties. One of them is physical resolution, which is based on the actual number of pixels on the device. For example, iPhone 4 has a physical resolution of 960 by 640. Now, our devices also have a logical resolution, which is basically how they behave. So iPhone 4 has a logical resolution of 480 by 320. Now, CSS is always based on the logical resolution. So when we say 200 pixels in CSS, we're talking about the logical resolution. Now, our devices also have another property called device pixel ratio, or DPR, which is the ratio of physical to logical pixels. iPhone 4 has a DPR of 2, but different screens have different DPRs. Sometimes the DPR can be 1.5, it can be 2, 2.5, 3, 4, and so on. And this might change in the future as we get more high-density screens. A high-density screen is essentially a screen with a DPR greater than 1, which means we have more physical pixels than logical pixels. All right, now the fun part. Earlier at the beginning of this section, I gave you a zip file with a bunch of images we're going to use throughout this section. In this zip file, you're going to find this file, mil-full. This is our mil image in full size. Now I'm going to use Photoshop to resize this image for 3 different DPRs, 1x, 2x, and 3x. If you don't have Photoshop, don't worry, you can use any other tools. Or if you don't have any tools at all, you can find the resized versions in this folder. So here we have mil.jpg, that is our 1x version. We also have mil at 2x.jpg and mil at 3x.jpg. So this is the convention we use for naming these files. We append at 2x or at 3x at the end. Now, what about the other DPRs like 1.5, 2.5, and so on? Well, we don't want to worry about them too much. 1x, 2x, and 3x should cover most of the screens out there. So now I'm going to open mil-full with Photoshop. All right, here's our image. First, I'm going to resize this for 3x screens. So on the top, we go to the image menu, then image size. Here you can see the original size, which is over 2300 pixels. We're going to change this to 1200 pixels. But why 1200? Well, let's say we want to display this image at 400 by 400 CSS pixels. So we're talking about the logical pixels. On a screen with a DPR of 3x, we want to provide an image that is 1200 by 1200. So 400 times 3, okay? Now, let's go ahead. Good. Then we go to File, Save As. So we're going to call this mil at 3x.jpg. Replace. Now in this dialog box, we can specify how much we want to compress the image. For JPEGs, a good rule of thumb is to set this to 7. We still get a good quality, but we get a lot of compression. So let's go with that. Good. Next, we're going to resize this image for 2x screens. So we go to Image, Image Size, and change the size to how many pixels? 800 by 800. So that is 400 times 2. Now we're going to save this file at mil at 2x, but I'm not going to do that. It's going to waste your time. What I want to point out here is that we should always start with the largest image. So 3x, then 2x, then 1x, not the other way around. Because if you start with a 400 by 400 image, and then use Photoshop to make this image twice as big, we're going to end up with a blurry image because Photoshop has to create new pixels to make our image bigger. So always start with the biggest size, okay? Now, back to index.html. Let's add an image with the class of meal. I'm going to set the source to images/meal.jpg. So that is our base image that is 400 by 400. Next, we give it an alternative text. We can say a bowl of salmon and curry. Now, to provide different versions of this image for high density screens, we're going to use the source set attribute. So with this attribute, we can provide a set of sources for different screens. We're going to set this to images/meal.jpg, followed by a space and 1x. So if the device pixel ratio of the screen is 1x, the browser is going to use this image. Next, we add a comma and supply a second source for a 2x screen. So we say images/meal@2x.jpg, followed by a space and 2x. And of course, we can reformat this to make it more readable. And one more source, images/meal@3x.jpg for a 3x screen. Now, let's save the changes. Unfortunately, Prettier plugin reformats our code, so that's something we have to deal with. Now we go to our style sheet and define a rule for this image. Here we're going to set the width to 400 pixels. Now, back to the browser. Here's the image we get. Let's open up Chrome DevTools and go to the Network tab, refresh the page. So on my machine, I'm getting meal at 2x because I'm on a Mac computer and the device pixel ratio of my screen is 2x. Now, let me show you what would happen if we didn't set the source set attribute. So I'm going to duplicate this image element. Now, for the first instance, I'm going to remove the source set attribute. So back to the browser, both these images are 400 by 400. That is coming from our CSS rule. But on the left side, we have an image that is 400 by 400 pixels. On the right, we have an image that is 800 by 800 pixels. If you pay close attention, you can tell that the image on the right is sharper. So using the source set attribute, we can provide high quality versions of our image for high density screens. But don't assume that you should provide different versions of every single image for high density screens. That's absolutely overkill. You only want to use this technique if you have a beautiful homepage with images that should look super sharp, then go ahead and use this technique. Also, this technique is for fixed size images. So in this example, we're displaying an image with the width of 400 pixels. That's our logical size, but we have provided 3 different versions of this image for standard and high density screens. In the next lesson, I will show you how to deal with images that should render at different sizes depending on the screen resolution of the device.